This is one of the most interesting problem from simultaneous linear differential equation. To solve this equation, we first differentiate one with respect to t. Okay, and we write here differentiate one with respect to t. We get the relation as we get from here d2x by dt2. This is equal to dy dt plus dz dt. Okay. Now using 2 and 3, we put the value of dy dt and dz dt here. We get the relation as x plus z plus x plus y. Here we write using 2 and 3. Okay. Now putting the value of y plus z, we write again here d2x by dt2. This is equal to y plus z plus 2x. We put the value of y plus z again from 1. We get the relation as d2x by dt2. This is equal to dx dt plus 2x. Okay, here we write using 1. Now we get the differential equation as d square minus d minus 2 into x equal to 0. Now it is easy to solve, and we easily factorize this relation and getting the result as d minus 2 into d plus 1 into x. This is equal to 0. So complementary function, here we write directly solution of x is given by x equal to, this is xc plus xp. xc means complementary function and xp means this is particular integral, and here xp, this is equal to 0 since right side term is 0. Here right side term is denoted by r, this is 0. Okay, so the solution is x equal to xc, the complementary function. And what is the complementary function? Clearly, two roots of the auxiliary equation are 2 and minus 1. So the complementary function is given by c1 e to the power 2t plus c2 into e to the power minus t. So we get the value of x, this is equal to c1 e to the power 2t plus c2 e to the power minus t. This is one value of the dependent variable x. This is x. Okay, we name this relation as relation number A. Now to find another two value of the dependent variable, that is the value of y and z, we subtract 1 or we subtract 2 from 1. Okay, so we write 1 minus 2 we get the result as dx by dt minus dy by dt. This is equal to y minus x because z and z cancel out. So from here we get d of x minus y by x minus y. This is minus dt because we take here minus common, and by integrating we get the result as log of x minus y. This is e to the power minus t plus, this is not e to the power minus t, this is minus t plus k. K is the integrating constant we laid here. Now x minus y, this is e to the power minus t plus k. This is e to the power k into e to the power minus t, and this relation gives x minus y. This is c3 into e to the power minus t. For e to the power k, this is c3 we laid here. Okay, now we put the value of x here. We get the value of y, and the value of y is given by y is x minus c3 e to the power minus t, and by putting the value of x here we get this is c1 e to the power 2t plus c2 e to the power minus t minus c3 e to the power minus t. So we get the value of y. This is given by c1 e to the power 2t plus c2 minus c3 into e to the power minus t, right? And this is the value of y, and we name this is relation number b. Now we have to find another value of the dependent variable, that is we have to find the value of z. But it is clear that we already take three integrating constant. One is c1, another c2 and another is c3. So we cannot use any other integrating constant because this three differential equation is of first degree. So total number of integrating constant to be used here only 3. Okay, so and we already use 3 integrating constant. So we have to find the value of z without integration, because integration gives another integrating constant. Okay, and for this reason we find out the value of z from the first equation again. How to find out the value of z from here? It is clear that z, this is equal to dx dt minus y. Now we put the value of dx dt from here. We get x is this, so differentiation of x, this is given by 2 into c1 e to the power 2t plus, this is minus c2 into e to the power minus t, because the derivative of e to the power minus t is minus. Okay, and minus 1 minus y, this is given by this, so c1 e to the power 2t minus, this is c2 minus c3 into e to the power minus t, and calculating we get 2c1 minus c1, so this is c1 e to the power 2t minus, we get c2 plus c2 minus c3 into e to the power minus t, and getting the result as c1 e to the power 2t minus 2c2 minus c3 into e to the power minus t. Okay, this is the value of z, and this is the last relation we have to find out, and this is C. Now relation number A, relation number B and relation number C together represent the complete solution of this simultaneous equation. Very interesting and important problem of simultaneous equation, right? Thank you for watching.